Hi everyone and welcome back to Dev Portal, your go-to channel for mastering Java and tech concept. In our last tutorial, we have learned about multi-threading, its benefit, and how threads are different from processes. Today we will take a step further and we will explore how to create threads in Java by using three different approaches. First, by extending the thread class. Second, by implementing the Runnable Interface. And third, by using Callable and Future. So let's get started. So let's start our today's discussion by creating threads by extending the thread class. Java provides a built-in thread class in java.lang package, and we can create a thread by extending the thread class and overriding the run method. The run method contains the code that will be executed by the thread, and we can start the thread by using the start method. Let me show you how we can do this. So first let me create a class. So I will write class and let me give this a name, suppose my thread. And I need to extend it by the thread class. So I will use extends keyword and I will write thread. And now I need to override the run method. So first let me add annotation @override, and then I need to write public void is the return type and run is the method name. So run method is the one where we need to write our logic. So what I'm going to do, I will write one for loop which will run 5 times. And I will print the current thread name with the counter, that what counter value of I it is accessing. So I will create for loop first. For int I is equal to 1, I should be less than equal to 5 so that it can run 5 times I plus plus. And here I will add sysout statement and I will print the current thread name. So for that I need to write thread dot current thread dot get name. So it will return me thread name, and then what I will do, I will print the value of count, that is I. So that's it. And now what I'm going to do, I will sleep this method for a second. So I will write thread dot sleep so that you can understand in a way that there are some other execution as well or some other logic as well which will take 1 second of completion. So I have used thread.sleep, so it can throw an exception. So let me catch this exception as well. So I will write inside a try catch block, and here what I will do, I will add sysout statement again, and I will write inside catch block due to, and I will print the thread name here, thread.current thread dot get name. So what we have done, we have created one for loop which will run 5 times, and we are printing the current thread name which is accessing this loop with the count value, that is the I value. And if that exception has occurred, in that case we have added sysout statement as well, and we have added the thread.sleep statement so that this execution can stop for a second. So now let me create the object of this class. So I will write my thread and let me give this variable a name, t1 is equal to new my thread. So one object I have created, let me create another object, my thread, and this time it is t2 is equal to new my thread. So 2 objects we have created. Now to start this thread I need to call start method. So I will write t1 dot start, and same way I will write t2 dot start. So that's it, and this is our first approach. So let me add comment as well. Approach 1, that is using thread class. So here we have extended the thread class. So first let me explain you what is happening here. We have overridden the run method which will contain the logic that our thread is going to execute, and we have called start method to start the thread execution, not the run method. That one point you need to notice. And the threads that we have created, t1 and t2, both are independent of each other. Let me show you how. First let me save this code and let me start the execution of this program. So as you can see in the console, it is printing the sysout statement, and if I go a little bit up, you can see it is printing thread 1, thread 0. Thread 0 represent t1, thread 1 represent t2, and both of them it is printing the count value as well. So with this, what we can understand is that t1 and t2 are independent of each other. So this is one of the ways that how we can create threads in Java by extending the thread class. This is very simple approach, but there is a problem in that. As you know that Java supports single level inheritance, and already we have extended the class, we are not able to extend another class. So to overcome from this challenge, we can implement the runnable interface. As we know, we can implement multiple interfaces in our classes. So by using runnable, it allows us greater flexibility as class can implement multiple interfaces, and we will overcome from this single level inheritance problem. So let me show you how we can do that as well. It is very similar to this, only just few things we need to change. So first let me create a class, and this time I will give a name my runnable, and this time it will implement a interface. So I need to use implements keyword, and here I will write runnable. And now what I need to do, I just copy paste this code. It will also override the run method, and same thing whatever my thread is doing, I will do it by using my runnable as well. So let me save, and first let me comment this line of code, and this is our second approach. So I will write approach 2, and this is using and I will write runnable interface. And now let me create the object first. So I will write my runnable. So I am creating the instance of this my runnable class. So I will write task is equal to new my runnable. So I have created the instance of my runnable class, and now let me create thread object here. So I will write thread t1 is equal to new thread. And one thing let me show you here. See here I can provide runnable object as well, which means whenever I am creating the object of thread class, I can pass my runnable instance as well. That is the task that I am providing to my thread to complete it. So here I will provide task, and same way I will create one more thread, that is t2 is equal to new thread, and this time as well I will provide task. So now let me start this thread first, t1 dot start, and let me write t2 dot start. Let me save and run this code. So you can see again it is printing sysout statement in the console, and if I go little bit up, it is similar. Thread 0 is t1 and thread 1 is t2, and you can see counter is there. Everything is same, just few differences there, that for thread we have used extend keyword because it is extending the class, and for interface, that is my runnable interface, I have written implements, and for both of the cases we have override the run method, and we have provided our business logic or logic that you want to implement or you want your thread to execute. So this was the second approach, that how we can create threads in Java using runnable interface. In both of the approach, if you see, we have overridden the run method, and the return data type is void. If I show you, if I come down for runnable interface as well, the return type is void, and for thread as well, the return type is void. What we can understand with this, that it will not return any value to us. So what will happen if we need a value? In that case, these things will not help us. So we need to use callable and future to overcome from this challenge. Let me show you how. So first let me create one class here. So I will write class, and let me give this a name my callable. And as callable is an interface, again I need to implement the interface first, and here I will write callable. And here I need to provide one data type. What does this data type mean? That what value I am expecting as a result after completion of the task. So suppose my expectation is integer value, that I will get an integer value once the execution is completed. So I need to mention here integer. And here as well we need to override one method, that is call method, this time not the run method. So first let me add annotation override, and here I will write public, and data type, return data type is integer, and method name is call. And let me add return type first, return null. So now what I am going to do here, I will again write one for loop which will run 5 times, and it will calculate the sum of first 5 natural numbers, suppose, and that natural number sum I want to return. So let me create variable here first, int sum is equal to 0. And now I will write for loop for int I is equal to 1, I should be less than equal to 5, suppose, and I plus plus, and we will add value of I in this sum. And after that, suppose let me add sysout statement so that we can print the thread name as well. So let me write thread dot current thread dot get name, and with that we will print sum as well, that is sum. And after that, let me add thread dot sleep, so that if there is suppose some other task are also there which is taking 1 second of completion. And one more thing is there, that with callable interface we can throw the checked exceptions as well. Let me show you. Here as you can see, it can throw the exceptions, so it is suggesting me to throw as well, or surrounded by try catch as well. So there is one more benefit is there with callable interface, is that we can throw checked exceptions with this. So this is done. Now here let me return sum. So we have created our class and we have extended the callable interface. As we know, Runnable does not return any value, but with callable it can return a value and it can throw checked exceptions as well. It will work with future to retrieve result asynchronously. That one thing we need to remember. So now what I'm going to do, first let me comment this line of code, and here we will use future to extract the value. So this is our third approach. So let me add the comment first, approach 3. And this here we are using callable interface. So now we need to create the object, and to create the object we need to use executor service. What executor service will do? It will manage the execution of callable task. If you don't know what these terms are, then don't worry, I will cover up these things in detail in the upcoming tutorial. For now you just try to grab the syntax and the way that how we are doing these things. So I will write executor service, let me give this a name, suppose exe is equal to, here I need to mention executors dot get, not get, new single thread executor. And now I need to define future, so I will write future, and as I am expecting an integer value, so I will write integer, that is future, and here I will use exe dot submit, and here I need to provide the instance of my callable class, so I will write new my callable. So that's it. Let me import future as well. And now what we are going to do, we will use this future object to get the value that this call method is going to provide. So let me write first try catch block, and here I will write integer, that is my result, is equal to future, and I will use get method to get this result, and that result I will print it here, sum colon plus not sum, that is result. And if it went to catch block, in that case let me add sysout statement inside catch block. So once our task is completed with the thread, what we need to do, we need to shut down this object exe dot shutdown. So that's it. Now let me save and run this method. So you can see in the console it is printing sum1, sum3, then 6, then 10, then 15 with a delay of 1 second, and then we have got the sum as well, 15. So this was the third approach of creating the threads. We have used callable interface, which was similar to Runnable, but it can return a result as well. The call method execute the logic and return a value, and the future is used to retrieve the result asynchronously, and the executor service help us to manage the execution of callable tasks. So to summarize, we have seen how we can create threads in Java using 3 approaches. First, by extending the thread class. It is simple and easy to implement, but less flexible due to single level inheritance. Second, by implementing the Runnable interface. It is a preferred approach as it allows multiple inheritance and it separates task definition from execution mechanism. The third approach is by using callable and future as it supports returning result from threads, enable asynchronous execution and exception handling as well, and work effectively with executor service for managing threads. Now the question arises when to use what. Then we can go for thread class when simple and standalone tasks are needed, and we can go for runnable interface when we want flexibility and separation of concern. And we can use callable and future when we want to return a result from threads. That's it for today's video on Dev Portal. If you found this video helpful, make sure to like, subscribe and hit the bell icon to stay updated with us. Notes link I will give you in the description box as well as in the comment section. You can check it out. And in parallel, I am also uploading videos on the database tutorial as well. So if you are interested, you can watch those tutorials as well. Have any question or suggestion, please drop them in the comments below. Stay tuned for our next tutorial on Java Threads series, and thanks for watching today's video on Dev Portal. I will see you in the next video.